The first time you see Devil's Tower from the Wyoming plains, it does not rise like a mountain. It stands like a remainder. The top is flat. The sides are ribbed in long vertical columns. Broken pieces of the same material lie around its base like fragments that fell away from a central mass. It does not look vague. It does not require imagination. It looks like a stump. Not metaphorically, structurally. And once that resemblance enters the mind, it becomes difficult to look at the formation the way the sign at the roadside asks you to. The official explanation is well known. Devil's Tower is igneous. Giant's Causeway is basalt. Tepuis are erosional remnants of ancient sandstone plateaus. Mesas are flat because hard caprock protects the top while softer layers erode away below. Petrified wood is what happens when buried timber is mineralized over immense spans of time. Carboniferous air once held more oxygen, which helps explain why giant insects existed. Each statement is defensible. Each one belongs to real geology. The standard account is not nonsense. It is built from evidence. The problem is not that the explanation exists. The problem is what it leaves unconnected. Because the contradiction is not one strange mountain. It is the repetition of the same visual grammar across the planet. Flat crowns. Circular or near-circular bases. Vertical ribbing. Debris fields. Plateau fragments. Root-like dikes. Immense table mountains standing alone over lower terrain. Columnar stone that resembles bundled fiber. Geological categories explain each example separately. But the eye is not seeing them separately. The eye is seeing a pattern. And the pattern is what no one wants to summarize plainly. That is where the hidden theory begins. Not as a demand that you believe the earth was covered in literal trees 40 miles high. Not as a claim that geology is fake. But as a serious archival possibility. Some of the formations we classify as plugs, mesas, buttes, plateaus, or erosional remnants may preserve shapes so biologically suggestive, at such repeated scales, that the standard explanation, while technically sufficient in parts, may still be psychologically incomplete. The forbidden part of the theory is simple. What if the stone is preserving the form of a lost biological world at a scale modern history cannot comfortably imagine? Not proven, but also not cleanly dismissed by appearances alone. Begin with the one case almost everyone knows. Devil's Tower is the gateway formation for this entire line of suspicion because its geometry is too concentrated to ignore. The flat top. The fluted vertical columns. The isolated rise above the surrounding land. The boulders at the base. The official explanation is that magma intruded below the surface, cooled, fractured into columns, and was later exposed as softer surrounding rock eroded away. That is the accepted model. It is not absurd. But what matters is not whether the explanation works in principle. What matters is what remains visible after you accept it. The formation still reads as a severed vertical organism more easily than it reads as buried melt. The eye does not let go. Then widen the frame. Giant's Causeway in Northern Ireland is explained as around 40,000 basalt columns formed when lava cooled and contracted. Again, real geology. Again, nobody needs fantasy to account for columns. But then the pattern repeats in Scotland, Iceland, Sicily, Tasmania, and elsewhere. Columnar basalt exists. That is not the question. The question is why the world preserves so many places where stone organizes itself into the same bundled, cellular, growth-like architecture. Uniform columns. Repeating diameters. Tight geometric packing. The official explanation is cooling fractures. The visual impression is a kind of frozen tissue. The two facts can coexist. And that is exactly what makes the subject difficult. There is also the matter of scale. We are comfortable with petrified wood because it fits inside the size limits our imagination accepts. A trunk becomes stone. A log becomes quartz-filled memory. The process has a name: permineralization. Mineral-rich water enters buried organic material and gradually replaces it while preserving aspects of its internal structure. The National Park Service describes this plainly in its discussion of petrified wood. The process is real. The chemistry is not in dispute. But once that fact is admitted, a more dangerous question enters. If organic structure can become stone while preserving form, what exactly prevents that process from being considered at far larger scales other than disbelief? Chemistry does not experience shock. People do. And that is where the atmosphere enters the story. The Carboniferous period is not fringe material. High oxygen levels are part of mainstream paleontology. Giant dragonfly-like insects existed. Gigantic arthropods existed. The world was different. Even if newer research refines the exact role of oxygen, the older atmosphere clearly allowed body plans and scales no longer common on Earth. The usual explanation is that lush forests and swamp systems produced this air chemistry. Fine. But that answer raises a second question. If the biosphere once supported oxygen levels and animal sizes that feel alien compared to the present, how conservative should we really be about ancient plant scale? The official model does not require trees the height of mountains. But it does require a world more biologically extreme than our instincts prefer. This is the point where serious people usually pull away, and the reason is understandable. It is one thing to say ancient life was stranger. It is another to suggest that some mountains might be the mineralized remnants of organisms so large that our categories of plant, geology, and fossil no longer sit comfortably apart. And yet the shape language keeps returning. The tepuis of South America are official erosional remnants of a once broader sandstone surface. NASA describes them as remnants of an ancient plateau. That account is coherent. But the visual effect is still extraordinary. Isolated table mountains rising like severed surfaces above jungle, their tops flat, their walls sheer, their bases distinct from the terrain around them. The explanation is erosion. The image is loss. Those are not the same thing. Now move to the American Southwest, where mesas are explained so clearly that they should end the mystery. A mesa is an erosional remnant. Harder rock on top protects softer rock below. The terrain around it is removed, and the flat-topped remnant remains. This is basic geology. It is true. It is also one of the strongest possible counters to the stump idea. But even here the pattern does not disappear. Because what the mesa explanation really says is that flat-topped stone masses can survive as fragments of a once broader level surface. In other words, what looks like a stump is often the remnant of something larger that has been removed. That does not prove biology. It does, however, preserve the emotional logic of the hidden theory. Something larger was there. What remains is only the resistant center. Shiprock deepens the unease. Officially, it is a volcanic neck with radiating dikes, magma forced through fractures and later exposed by erosion. That account is structurally sound. But from a distance, shiprock looks less like a neck and more like a central trunk sending stone roots outward across the desert. The dikes run like spokes, but to the eye they also run like a root fan. Again, the official explanation can be correct, and the resemblance can still matter. That is the theme of the entire investigation. The data is not necessarily false. The categorization may simply be too narrow to absorb the psychological pattern. There is a tendency, when confronted with a repeated anomaly, to assume that science must already have tested the obvious alternatives. Sometimes it has. Sometimes it has not. What is striking here is not that geologists refuse to explain these formations. They explain them constantly. What is striking is that almost nobody seems interested in addressing the biological resemblance directly in a way that closes the loop for non-specialists. We are told why a plug forms, why a mesa survives, why basalt columns fracture, why petrified wood mineralizes. What we are not told is why so many unrelated explanations leave behind landscapes that resemble the remains of a world built on growth, severance, and petrified anatomy. That omission may not be sinister. It may simply be disciplinary. Volcanologists explain magma. Sedimentologists explain plateaus. Paleobotanists explain permineralization. Atmospheric scientists explain oxygen. Geomorphologists explain erosion surfaces. Each field stays inside its own lane. The result is that nobody is rewarded for assembling the full visual pattern into one uncomfortable question. And where institutions do not synthesize, speculation rushes in. Not because speculation is strong. Because the silence between specialties is. There is also an archival reason the theory survives. Early surveyors and travelers often described formations using biological comparisons. They wrote of trunks, roots, fibers, columns, bark-like textures, and cut surfaces because that was what they saw before later technical vocabulary stabilized. Over time, those comparisons were absorbed, softened, or treated as poetic. That is how institutions handle unsettling resemblances. They do not always suppress them. Often they rename them. A stump becomes a neck. A severed surface becomes a remnant plateau. A root fan becomes a radial dike swarm. The geology may be accurate, but what changed was the explanation. The strongest counterargument must be taken seriously. Human beings are pattern-seeking animals. We see faces in clouds and intention in random fracture. We are exquisitely vulnerable to false resemblance. Once someone says, tree stump, many people will see tree stumps everywhere. That is true. It is probably true often enough to explain part of this entire phenomenon. But pareidolia has limits. It explains one or two suggestive forms. It does not fully explain why similar visual cues recur across plugs, mesas, basalt fields, tepuis, dike complexes, petrified forests, and ancient highlands in ways that keep pointing back toward the same biological vocabulary. At some point, repeating resemblance becomes data of its own, even if the conclusion remains uncertain. And then there is the largest discomfort of all, time. Hidden history theories often fail because they compress everything into one event. One catastrophe. One civilization. One cut. Real geology does the opposite. It takes one apparently simple form and stretches its making across millions of years. That is what may be happening here. The cut is not one cut. The stump is not one stump. The Earth may simply preserve, in layers and fragments, the remains of processes so vast that the shapes they leave behind resemble biological forms because biology itself evolved inside the same laws of structure, pressure, fracture, support, and flow. That is the most conservative explanation for the resemblance. It is also, in its own way, the strangest. It suggests the planet naturally generates ruins that look like life because life and geology were never as visually separate as we pretend. Still, the alternative possibility refuses to disappear. If the world once supported plant forms or plant-like megastructures far larger than the fossil record comfortably demonstrates, and if some of those forms were mineralized, shattered, buried, uplifted, and eroded over unimaginable time, then much of what we call mountain, plateau, and plug would not need to be reclassified all at once. Only a few confirmed cases would be enough to force a rewriting of scale. One verified example of a mountain-sized biological remnant would not merely add a species to the fossil list. It would alter the border between geology and paleobiology. That is why the subject never quite dies. Not because the theory is proven, because the cost of even partial confirmation would be enormous. So what remains after all the spectacle is stripped away? A set of official explanations that are individually strong. A set of visual patterns that are collectively stubborn. A real process by which would become stone. A real history of a more oxygen-rich world with giant arthropods. Real flat-topped mountains formed by erosion. Real volcanic necks with columnar fracture. Real table mountains preserved from older surfaces. Real dikes radiating from central cores. And over all of it, one repeated sensation that geology has described every piece without ever resolving the whole feeling. The stone remembers. Not necessarily what the hidden history channels want it to remember. Not necessarily giant forests taller than continents. But it remembers lost surfaces, broken masses, preserved structure, vanished layers, and worlds that no longer exist in the forms they once held. The public sees a stump. Science sees a plug, a mesa, a plateau, a remnant, a dike, a fracture system. Both may be looking at the same object from opposite ends of understanding. That is the final reframing. The tallest trees on Earth may never have existed in the literal form the theory imagines. The mountains may be exactly what geology says they are. But the reason the theory keeps returning is not ignorance. It is that the Earth keeps presenting objects whose shape, context, and repetition trigger the same impossible recognition. Something was larger. Something was removed. What remains looks less like creation than aftermath. And the real question is not whether the theory sounds strange, but whether anyone with the tools to verify it has seriously looked.